Hello, this is an introduction to AI and its synthesis with BI. Another way of presenting the concept I have between AI terminology and BI terminology is to discuss it from the perspective of the Rosetta Stone, which allowed us, after thousands of years, to finally understand hieroglyphics, because the Rosetta Stone had three sources of the script in it, and that is important. We'll see. Also, I'd like to apologize. I have a slight slur, which I'm working on clearing up. It is important to me to note these are my observations. Ira Warren Whiteside. And I would welcome any critique, correction, enhancement, addition that you may have. Hey, I don't want to belabor you with my history. Let's just say I've had a lot of experience in both BI and AI. If you look at the current slide, I'd like to take you through about 4 slides and informally discuss terms that generally need to be explained, and many of which kind of mean the same things but are thought of differently between AI and BI. It's not perfect. I've got a lot, frankly, that I can learn, and I wish to ask you to participate by leaving a comment in the section below. You can have the slide deck. I have nothing at this point to sell. I just want to get out and help people understand on both sides. So you'll see at the top, I have 4 columns. I have a term, generally, specifically the IT BI term. I then have an AI term and a description. This is definitely a work in progress. And as you'll see, it represents my understanding currently with the explosion of LLM or Chat GPT. There seems to be an acceleration and, frankly, a great gap between people who understand BI and they have value and people who understand AI, and of course they have value, but there are many redundancies happening which are not necessary. Okay, so you can see simple terms like iterative design. We can certainly say in ITBI it's agile, but generally in AI it's referred to as tuning or configuration without a real understanding of what they're doing to the model. To get to an iterative, what is a design? It's many, many things not clearly explained. It's better understood on the BI side because we've been doing it longer. It will get there on the AI side. So there's an older term from the 80s, which is rapid prototyping. That has also been folded into agile or iterative, but that's still primarily a part of tuning on AI. And we'll get to prompt engineering and a few things later. On the left-hand side, under term data quality, obviously in BI and IT, it's data quality and well understood and common. But you know, in AI, it's now a part of data preparation. What I aim to clarify is all the things that were done before still need to be done. However, there are some misunderstandings as to what those tasks are. Data quality on the left, the second data quality called data quality. It's in IT and BI terms, it was still data quality. But in AI terms, it's not generally recognized because it can be both in data preparation and, more importantly, with the advent of LLM, it's hallucination. No, it really needs prompt engineering. We'll talk about that. Or retraining of the model. We'll get into details. On the left, you'll see the next is configuration. In BI and AI, it meant many things. Models, rules, ETL, ELT, and database. Those were all extensive designs and work. Frankly, much of that work is still needed. However, in AI, a lot of that is the algorithm you choose for your model and maybe the embeddings. It can mean more. I'll accept any criticism, input, advice you guys have. Next, under the left-hand side, we talk a lot about reference data. That becomes critical, and we'll get to it in AI. But first, in IT and BI, it was master data management, product information management. The relationship link between input data that's dirty and business data or terms that's clear. In AI, it's generally now seems as the relationship or vectors or graphs, knowledge graphs, and how data terms, that actually data input, which is fields or dimensions, relate to each other. And that's determined by model and by nearness. But that needs quite a bit of refinement for context. You need to accomplish prompt engineering or configuration at startup, which we'll talk about. Again, it's really the incorporation of business reference data, but how you do it in each discipline is a good bit different. Next, you'll see natural language processing. So in IT, we certainly used, and BI, natural language processing, early forms of AI. However, I don't have this quite down yet for A because surely it's a part of LLMs, large language models. But it's part of what I said is reference data. It's a way for you to associate a vector or a term with the real data. To their purpose in LLM is trying to predict the next word. It's got to be the right word. It's got to be a word that makes sense. So that would involve both reference data and NLP. Next, we'll address some more terms. So at the top left, you see the term artificial intelligence. In IT and BI, while we did use some algorithms, fuzzy matching, edit, distance, what have you, NLP, it wasn't widely recognized that we had it. It was there, but it wasn't widely recognized. So I'd like to hold my fire a little bit on that. Artificial intelligence, a predictive flowchart process with business questions leading to answers based on actual facts. That would be my rather lengthy definition. And we really didn't have it broadly in IT and BI. However, in AI, I would like to offer that it will take into account historical trends as well as other data. And we'll talk about that more because it has many nuances and meanings, meaning different things to different people. First of artificial intelligence, LLM, large language models. Again, we haven't really explored that in the past. It is now the foundation for ChatGPT, along with some other capabilities. In IT, it's basically, in reality, a neural network model built with the transformer model and NLP. My basic difference is it is not for math. It is for words. Without getting crazy, I can explain later. On the left, we have matching. Okay, certainly we've done that in the past, fuzzy matching. It's in many ETL technologies and what have you. Data quality, yeah, we've seen it, we understand it. In AI, it's used, but basically it's limited and not well recognized. It's used heavily, although you wouldn't know it. It basically is the incorporation of edit distance algorithms, like Jar-Winkler, whatever, Levenstein, but again, generally not actually recognized. I could actually put some definitions of nearest neighbor in there, but I wanted to keep it at a high level for now. Next is statistics. All right, in under IT and BI, you see me, I have defined by Gartner, GAU. No, it's defined by Gartner as data quality. There are generally recognized a collection of statistics, mean, max, min, mode, spaces. We have that technology in many forms. On the right, you'll see, actually in that case, it's going to be particular, no bad spelling, to a specific algorithm. And that we'll talk later. It's important to understand that you need to feed an algorithm, not every data column or data field you have, but what you think is important. And we'll talk about the way to do that through a special function, PCA, Principal Component Analysis, later. Next, you see on the left, algorithms, mostly implemented in data profiling. We'll cover in data profiling, okay? Except for, of course, matching, which is a set of algorithms. In AI, you'll see there are many AI algorithms, including linear regression, logistic regression, decision tree, SVM algorithm, naive Bayes. There are many, many. But again, each one of them you would use differently depending on the business question that's being asked. In many cases, that'll have relations to what we knew in BI as KPIs. Okay, one more to go. Now this is not complete. Again, I don't want to be declarative or even definitive, but I'm giving you what I understand after working in both fields for many years. Data profiling certainly is qualified as data profiling in BI and IT to create statistics about input data. In AI, what I see is it is buried in principal component analysis, which is a standard algorithm used to determine elements' relation to a particular model and how it's going to be used. What fields matter? It's mainly performance. I don't want 100 fields if I only need 3 to make the model work. Thereby, it's different based on what you're going to do. So I feel there's a need, even in AI, for both. but you need to do general data profiling first, and then follow it up with a shot of PCA depending on your need. So to wrap it up, the Rosetta Stone was very important, and the only way we ended up decoding and understanding things written in completely different languages. Frankly, it's very similar to the current state of affairs. Many things are shared: verbs, nouns, parts of language. However, we need to be able to